All right, we are in Chapter 6, Unit 1 here, trying to finish up some practice problems here, and I believe we should be done after this one. It says hens usually begin laying eggs when they are about 6 months old. Young hens tend to lay smaller eggs, often weighing less than the desired minimum weight. So it says the average weight of the eggs produced by the young hens is 50.9 grams, and only 28% of their eggs exceed the desired minimum weight. If a normal model is appropriate, what will be the standard deviation of the eggs, basically? So it says right here when we're doing it, the average weight of the eggs produced by a young hen is 50.9, so we got that. And only 28% of their eggs exceed the desired minimum weight, right? 28% of them. So exceed that. It says only 28% of their eggs exceed the desired minimum weight. The normal model is produced in order to figure it out. So if we know that it says the minimum weight, because it says young hens tend to lay smaller eggs, often weighing less than the desired minimum weight of 54. So if I know that that's 54, I can try to find the standard deviation because it's not given to us, basically is the point. So when we're doing this, trying to figure out exactly what that is when you're given it, we have the mean, we have the 54, right? And basically what we can do with the standard model when doing this is, if I know that that is 28%, then I know this way is 72%. So I could just do inverse norm in the calculator 0.72, and when I do that, it'll tell me the z-score of that 0.583. So I put that there. So now I can multiply by the standard deviation. That's 3.1. Or sorry, yeah. Divide by that and figure out that my standard deviation is that. So it's just a crafty way of why you need to remember what the z-score formula is, because the calculator won't do this for you, but you can then manipulate it to figure it out, which is why it's important that you can't just forget about how to find the z-score, because they might want you to manipulate problems otherwise. So that would be the standard deviation of it. By the time these hens have reached the age of 1 year, the eggs they produced average 67.1 grams, and 98% of them are above the minimum weight. All right, so if that is now the minimum weight is 54, right, and it says by the time when the hens have reached the age of 1, so it's a completely different model now, the eggs they produced average this. And now I want 54 as the min, so I have that. And now it says, what is the standard deviation for the appropriate model for the older hens? Well, that's 98%, that's 0.2, or sorry, 2%, or 0.02 this way. So now that I know the z-score again, by doing inverse norm of 0.02, 0, 1 of the standard model, I now know the z-score, I know the difference between them, I multiply by the standard deviation and divide to find out that the standard deviation of these older hens I was able to find is 6.377. And then it says for part C, are these egg sizes more consistent for the younger hens or the older ones? And so the younger hens lay eggs that have more consistent weights than the eggs laid by the older hens. The standard deviation of the weights of the eggs laid by the younger hens is lower than the standard deviation, which means they are closer together, which makes them more consistent. The idea here is hopefully you got a ton of practice if you were stuck. I don't expect everyone to do all these problems and understand all of them instantaneously, but the ideas are here for you guys to look at whenever. And I must have done, honestly, close to 30 problems related to this section and this chapter. I'll do some more here that kind of review everything for your test. This is a good background for all of you to make sure that you understand how this stuff all works. And then we'll have our test, and I think we should be good to go from there. If you have any questions on anything in this chapter, please don't hesitate, or sorry, chapter, yes, but also in this unit, in Unit 1 and Chapter 6, let me know.